if you understand the consulting business, you would start to see these patterns. So you usually start with platforms, right, which are mostly to do with quick results that, let's say, you wouldn't have usually, but is achievable through platforms and not too much expense into, let's say, hours spent, or let's say not as resource intensive, let's say, compared to the other things. So that's how you usually start with platforms, and the recommendation systems, for example, become the sort of the hot topic, because there are a lot of platforms, including the stuff that we build, that can benefit you there. So that becomes a good starting point. But once you start to see the benefits of this, this can basically be applied to anything. Let me give you an example. So one thing that we did talk about was inventory and logistics optimization, right? So where is the demand going to come from? Forecast that, and therefore you know where to ship stuff before the order actually arrives. That is one kind of prediction. The other kinds of predictions you could make could be to do with, let's say, quality assurance, which could reduce the amount of time it takes for you to QA any product of yours, whether it is to go on the e-commerce platforms that you have, or whether it is to, let's say, QA something that you put up in a store physically. A lot of research has gone into that, into classification systems, let's say, which can classify whether something is ready for marketing use or not, right? And that can be programmed based on the kind of things that you would look for when you were doing QA manually, and you can optimize or automate a lot of that into these processes that are then automated. Reduces your turnaround time from production to sales, and therefore helps your top line. And I believe it also has cost implications, so helps your bottom line as well. Beyond that, I think there's other examples. So let's say an industry like the motorsport industry, if you take that example, you run simulations of laps. So Formula One, for example, would run millions of simulations of the cars based on their current performance data, running laps around the circuits that they're going to race at, and then optimize the strategy that they would use inside the race to avail the minimum time spent in achieving, let's say, 70 laps around the racetrack. So what kind of tires to use when to come for the pit stop, so that your rivals who you are fighting in the race are at the most vulnerable point, or let's say when do your strategies have the most opportunity to pass your rival on the racetrack, things like that. Of course, now everybody's doing it, so you have to fight. Essentially, these are AI systems fighting against each other. So everybody's running these billions and millions of simulations and trying to optimize the strategy.